Hey guys, phone died on the last time I tried to explain this, so I'm going to try it again. Question 7 on the complex numbers booklet. I'm looking at this diagram here where they give you Z2, A, and Z, and OQR are equilateral triangle, and OPR is also an equilateral triangle. They give you W, which is cos pi on 3 plus I sine pi on 3. They give you that Z1 is equal to, the modulus of Z1 is equal to the modulus of Z2, which equals the modulus of Z of A, which is equal to 1. So first question they want you to do is explain that Z2 is equal to W times A. So what you have to recall is that Z1 times Z2, when you multiply two complex numbers together, if they're written in this cis form, do you remember what the shortcut was? It turned out to be R1, R2, cis theta, theta 1 plus theta 2. Do you remember that? So what this means essentially graphically is that you multiply the modulus together, okay, and the arguments get added together, okay. So to explain why Z2 equals WZA, well, W has an argument, okay, of the arg of W is equal to pi on 3, okay. Can you see that? So if you start with A and multiply it with W, then remember what happens to the argument? The arguments get larger. And the way we add the arguments together, it's always clockwise, anti-clockwise from the real axis, okay? So if we started with A and we're multiplying it by W, which is 60 degrees or pi on 3, then essentially you're going to end up in this line here, right? This ray. So because this is pi on 3, okay, and that's given because this is an equilateral triangle, okay. And the other thing to keep in mind too is, okay, what happens to the modulus? Well, because these two modulus are both equal to 1, it's also going to be at that point there, which is a distance of 1 from the origin. Okay, so it's going to be along that ray or pi on 3, away from R, A, and it's going to have a length of 1. Okay, so how do you go about writing? So I would start by saying that this angle in here is pi on 3. So I would say that since in triangle OQR, angle R OQ equals pi on 3, since it is equilateral. Okay. So I would also say that multiplying A with W, what was it? Would involve an anti-clockwise rotation of a arg of W which equals pi on 3. Yep. And I would also say that therefore Z2 equals would be A times cos pi on 3 plus I sine pi on 3, which equals AW. Okay, something that shows you that you realize that both of them have a mod of 1 too. So I'd say the mod since the mod of A equals the mod of Z2, therefore that's true. Okay, it's only a 1 marker, so you don't have to be too detailed for that. Okay, question 2. Okay, so question 2, you had to show that Z1 times Z2 equals A squared. Okay, so from part 1, we know that Z2 equals WA. Okay, what would be an expression for Z1? Well, Z1, back up to here, is virtually the same, but you're going the opposite way, right? Instead of multiplying, which goes anti-clockwise, if you divide, it sweeps it in a clockwise direction, right? So if I divide it by, so start with A and divide it by W, okay, because W has an argument of pi on 3, and this angle is also pi on 3 because it's an equilateral triangle, then Z2, so Z1 would be equal A divided by W. Does it make sense? So if I'm doing Z1 times Z2 would equals WA times A over W, then our W's cancel out. I'm just left with A squared. Okay, so essentially this bit's the important bit. Okay, there's other ways of doing it, but that's probably the most easiest for that 1 mark. Okay. Okay, so the third question says show that Z1 and Z2 are the roots of Z squared minus AZ plus A squared equals 0. Okay, so firstly, let's use part 1 and part 2. So Z1 was equal to, what was it? Was equal to A over W. And Z2 is equal to AW. Okay, so let's rewrite these. Let's write this one out first because it's easy. We know that A is A and W is cis or cos pi on 3 plus I sine pi on 3. Okay, so if I want to expand this out, it will be A cos pi on 3 plus I A sine pi on 3. Okay, this one on the other hand, I would have A over cos pi on 3 plus I sine pi on 3. Okay, if I just want to write this one out, I want to rationalize the denominator because this is ugly, right? So cos pi on 3 by the conjugate, multiply by conjugate, sine pi on 3 over cos pi on 3 minus I sine pi on 3. Remember, this just changed the form of it. Look what happens at the bottom, right? You're going to have the difference of 2 squares. The top's going to be this, cos pi on 3 minus I sine pi on 3. Now notice the bottom. The bottom is going to have difference of 2 squares. It's going to be cos pi on 3 all squared minus I sine pi on 3 all squared. Okay, so cos of pi on 3, remember that, 60 degrees. This is root 3, 1, 2. Okay, cos is going to be a half, so that's going to be a quarter. So this is going to, half squared is a quarter. Okay, this guy, because I squared is going to be minus, it's going to change to a plus. So you're going to have a plus down here. Okay, sine of pi on 3 is going to be sine. It's going to be root 3 on 2, but I have to square it. So it's going to be root 3 squared is 3 over 2 squared is 4. So I've got 3 over 4, okay, plus 1 over 4, okay, gives you the 1. So that whole denominator disappears. So that's your expression for Z2. Okay. Now, let's see how it relates. Okay, I've got these two expressions for Z1 and Z2. Let's see how it relates to this quadratic we've got up here. So Z squared minus AZ plus A squared equals 0. So how do you solve a quadratic? We can try factorizing. If you're too lazy like me, chuck it in your quadratic formula. That'll be A plus or minus the square root of A squared minus 4 times 1 times A squared, all divided by 2 times 1. So it's A plus or minus the square root of, that's A squared minus 4A squared, so that's minus 3A squares, all over 2, which equals A plus or minus the square root of minus 3 is going to be root 3I, square root of A is going to, so A squared is going to be A, all divided by 2. Okay. Okay. And so what we're left with is this. Z equals A outside, or A plus or minus root 3I A over 2. Now, another way of writing this is A outside of 1 plus, or 1 over 2 plus root 3 A over 2I, or A plus, or minus root 3A over 2I. Now, this is actually equal to your expression here for Z2, okay? Because the cos of pi on 3 is equal to half plus IA, this is root 3 on 2. Okay, so you just have to show that. And this one's actually equal to Z1. Okay. So hopefully that's how I did it. I think the answers and the solutions are a little bit different, but there's heaps of different ways to get these questions out. Okay, that's just the way I thought of it. Hope that helps.